Going, everyone? Thank you. Well, I really appreciate you guys making it out here. I know how hard it is to get moving after lunch, but I think you guys are going to find that you're in for a treat. Welcome to the afternoon session of Microsoft Ignite the Tour. Today we're going to be talking about how to take your models and your machine learning environments to the next level with Azure Machine Learning and some of the more advanced features of the Azure Machine Learning Service. Before we get started, all the resources, everything you see here is open source, available for getting started with. So you can take a picture now, and also I'll show the slide again at the end. And with that, when you guys are ready, we'll get started. So I'll give you guys just a second here. Perfect, and then let's keep moving. So before we get too deep, I'd like to always start with a little bit of perspective. So one of the things that I think is incredible over the past 5, 6, 7 years is we've seen huge advances in the way that machine learning and AI impacts day-to-day digital transformation. And we see that in a wide range of applications and industries. Applications such as predictive maintenance and e-commerce, all the way to computer vision and some of the things that you saw earlier in David's sample and AIML40. Things like forecasting and time series analysis, autonomous agents and reinforcement learning, like we saw in the keynote that we discussed earlier today. And one of my personal favorites is the field of language understanding. Now today, we're going to be focusing just on language understanding, but I want to keep it clear that everything we're doing and everything I'm showing you today here with regards to natural language processing and language understanding and training these models can be applied to every one of these domains. So before we get deeper, let's dive a little bit deeper in what that means and why language understanding is important. So for me personally, I see 3 major trends when I'm meeting with customers or I'm talking with developer communities in this area. And the first major trend that we see is the progress and the importance of natural language understanding for ambient computing. So imagine if you guys have had a chance, and if you haven't, I recommend getting on the showroom floor and checking out the HoloLens 2, the ability to interact with your environment through ambient computing, things like Cortana and being able to speak to devices and interact and have them understand and be able to process natural language in something that can provide more contextual, individualized experiences. The next area that we see a ton of interest in this field is through automation and scale. So whether it's, for example, a CRM system that you're running, or whether it's through automating traditional work processes that are simple for a human, but they are traditionally challenging for rule-based systems. So for example, if I'm a lawyer and there's a set of contracts, for instance, that I want to that I'm pretty comfortable with classifying, right? I can say this is an interesting contract of this type or not an interesting contract of the other type. Being able to automate that so that the lawyer doesn't have to focus on that, and we can, instead of paying $400 an hour to classify these documents, have them focus on the things that they do best. That element of empowering and automation and scale, things like chatbots, being able to, instead of having to deal with complex systems where we're just giving the same very basic questions to our customer support, being able to automate some of those questions and reduce the load and scale that. That's another area where we're seeing a lot of these applications take form and shape, and why a lot of these elements are super important. And the last area that I think is often underlooked, but I think is super important, and why natural language processing is one of my favorite areas of AI, is the ability to unlock unstructured data, incorporate that into the traditional modeling, data science, and ML process. So you can imagine, for example, in the past, if I have a CRM system and I want to do something like be able to predict whether a customer is going to buy something. In the past, I might look at the records of when the date was, when was the last transaction, what are these numerical and categorical features. But often, for example, I might have the salesperson write a comment, and that comment could change and provide new context for everything that is in my CRM record. So as an individual, if I could have stronger natural language processing models and be able to incorporate that textual context into that record when I'm modeling that with other traditional approaches, all of a sudden I have a lot more context that I can use to provide more expressive models for everything we do, whether that's in the medical sector, whether that's CRM systems, or whether that's retail. And I want to tie that through to the work that we've been doing with Tailwind Traders. So how many of you by now are familiar with the concept of Tailwind Traders? Good. I'm glad. It means that a lot of you have been coming to the sessions today. So essentially, Tailwind Traders is a global retail brand. And as a global retail brand, they have global retail challenges. And in this talk, we're going to be focusing on a specific case study that they did where they wanted to enter a new retail segment. They want to essentially push out a new line of online clothing, and they want to be able to identify, based on the textual feedback, not just simple reviews of 1 to 5, but based on the textual reviews that people are leaving, they want to be able to measure that sentiment so that they know how to improve the end customer experience. So let's take a look at how we can get started without even a single line of machine learning code at the very high level and how we could solve this problem, right? So those of you who were at the cognitive services, how many people here are familiar with cognitive services by this point? Probably mostly everyone. For you, those who aren't, cognitive services allow us to get very, very quickly started with here. We can take each of the reviews, we can pass them as text, and we can get structured data back. We can quickly identify named entities, we can get key sentiment, and we can do this in near real time. So I can show you real quickly how we could get started with this. So I take my text analytics thing here. I say, I love the Orlando store, right? One click. We get back the result. We can view this result in JSON, and we can provide this context to our application. We know now that our location in Orlando is getting positive sentiment, and there's some insight that we can do to improve that customer experience when we're Tailwind traders. So again, that's very good for getting started with AI and getting started with your journey. And again, why would I think of doing these types of things? Well, because they're easy. I don't need to be the machine learning specialist or the AI specialist. I can leverage a lot of the great work that larger companies like Microsoft have done. It directly supports each of my application environments, whether that's Windows, Android, iOS, whether that's in languages like traditional .NET, all the way to Python and Go and JavaScript, right? And when I have challenges and I run into issues there are supported communities and PMs that I can ping who can help me understand what's going on. And that's great. If you're interested in getting started with this, all the documentation's here. You can take a picture. But we want to go a little bit deeper. And why would we want to go deeper? I mean, I just said that this is a great service, and it really is. But what I think when I've done a lot of work in this space is there tends to be an 80-20 rule. Now, in software development, we have a lot of these. There's even a technical rule for these 80-20 rules, like the Pareto optimum, right? One of my favorite ones is that 20% of your code is responsible for 80% of your bugs, right? Well, in AI, I say that there's one of these as well. There's about 80% of the use cases that you want to do as a business are probably already addressed by one of these general supported cognitive services that you can incorporate in your application. That being said, that remaining 20% tends to be the use cases that provide 80% of the most business value. And so instead of reinventing the wheel on everything, I think it makes sense to focus that 80% of the effort that you can automate with a supported system, leverage the supported system that's being constantly supported, iterated on, and built upon. But when you need to dive deeper, you should be looking at deeper tooling. And so in Azure, we provide the Azure Machine Learning Service. And the Azure Machine Learning Service is a Python SDK that wraps many of the AI services that we have in Azure. It enables you to do things like model preparation, train your models, deploy your models, track experiments, and enables you to better iterate your models. And this whole concept of the Azure ML Service runs around something called the Azure Machine Learning Workspace. And we're going to dive into this real quickly right now. The Azure Machine Learning Workspace allows you to manage your compute, the different experiments, your data, the pipelines for end-to-end ML ops. Everything that you kind of need is all in this workspace. And you can integrate with it through the UI or the Azure Machine Learning APIs. So let's take a look at what this looks like. So to get to the service, all I have to do is ml.studio. I create my workspace, and I'm in my workspace. And the first thing that I'm going to want to do is I'm going to want to upload a data set so we can start modeling and doing something a little bit more complex. I'm going to take a step back, and we're going to show an example of why I would want to do this for something like sentiment analysis. Let's say I'm Tailwind Traders, and 90% of the queries that I put in, I get the results I'm expecting. I put, I love the Orlando store, and I get 80% back sentiment. I put, the Orlando store could be improved. I get a completely different score. But I start noticing some weird things when I have just pre-built models that I might want to customize. So for instance, if somebody had a typo or speaks in Shakespearean English, right? And they type, I loveth the Orlando store, all of a sudden, I get unexpected results. And now, again, these are pretty rare, and these aren't necessarily things that will address every single use case I have. But when I do run into these things, and if they do impact my business, then I want to build something more custom. And so what we're going to do is we're going to build, before we go and build models, I like to build a baseline. And what we're going to do is Azure Machine Learning provides what's called the AutoML service. Very, very quickly allows me to enter data, whether that's text data, define goals, whether that's goals for building a model that does classification or sentiment on my own data, apply constraints. And what it will do is it will go and try out many different parameter configurations and model architectures. And it will go and try to return to me the best parameters and the best architecture for my data set that optimizes the goals and the constraints that I've provided. And so let's actually look how this works. I'm going to preface that these types of models, they're not the things that necessarily are going to give you the state-of-the-art model, but they are going to give you the end-to-end baseline that can take you from your data to getting a model that's more customized for your use case. So let's look at how this works. Again, I'm going to go back to my Azure Machine Learning workspace. I'm going to upload a custom data set around a clothing experience, a lot more aligned with Tailwind Traders. And we can upload and profile this so we can explore some of this data. I can view here, I have a bunch of texts. So for example, love this dress. It's so pretty. I happen to find it in a store. And I have a bunch of ratings from 5 to 0 to whatever, from 1 to 5. And then I can use those ratings to build a model that serves similar to a sentiment classification, predominantly for my domain. So it allows me to do some customization that I otherwise would not be able to do with an out-of-the-box model. So how do we go about doing this? Well, the first thing I'm going to do is I'm going to go to Automated ML. I'm going to click New Automated ML Run. All I do is I select my data set. So I have this clothing data set. And I just need to do some very basic things. So the first thing is I need to give this an experiment name. We'll call it Clothing Sentiment. The next thing I need to do is I need to select a target. What's the thing that I want to optimize? So in this case, we have a bunch of review text. And we want to try to predict a rating based on that. And given this rating, it will help us understand sentiment from data we've never seen before. And then the last thing that I need to do is choose a compute target. In this case, I can choose a very basic compute target. If I want to create a new one, I can do things as simple as very, very low, cheap CPUs with limited small amounts of memory, all the way to huge clusters with tons of, we have over 1 terabyte of RAM and multiple 24 CPUs and multiple GPU compute. So I've already created a compute target here. Let's go build a model out of this. So what we can do is we have a couple different configuration settings that I can set up. So I can choose how long I want to run the different experiments. If I run them longer, they take longer. They use a little bit more compute. But I might get better results. I can choose what kind of validation I want to do, whether that's cross-fault validation. This is how I would take my data set, split up my data set, and validate that the data set is giving me good results. Or I can put in my own split, test train split, and I can run the amount of iterations I want, and I can choose from a whole list of metrics that I want to optimize for this. And then when I'm done, I just click Save, and I run the job. And what it will then do is it will go and choose many different architectures to build out and experiment in parallel multiple versions of a model. And one additional thing here is we have text. So again, I can auto get this text information, but I can also choose text here, and it will help me deal with processing those features to train a model. And I'm going to show you guys a run that I've already run and show you how powerful and how quickly it is to get started with this service. So I have this model that we did. We clicked Run here. We can go in, select the run. I can see all the different models that were trained. I can see the metric that I chose here, and I can see the best performing model. I can choose a specific model if I want to dive in a little bit deeper, and I can go into the visualizations. And as it loads up, I can see all the traditional metrics for each of the different models that I think I would consider, and I can see the trade-offs for how to deploy them. Things like precision and recall, ROC, my lift curve, calibration curve, even the confusion matrix based on the k-fold split that the model chose. For specific models, we even can dive deeper with explanations and doing some really, really, really cool stuff there. And when I'm ready and I think this is a good model, all I have to do is click one button on the run. And I can either download that model locally, or I can just push that model, click deploy, put in the name, put in the compute target that I want to run the model, and I'll have an endpoint on this model without writing a single line of ML code that I can now evaluate against as a standalone service. So you imagine that's very, very powerful. We've now gone through and covered a lot of ground here from the top up of how we go and use standard traditional cognitive service models to get started with incorporating textual information and classifying the sentiment reviews. We also showed how there's some constraints there and how we can take that one step further to build baselines using AutoML service that I can use to get better and more custom sentiment for my case. Now let's take one step further, right? Well, this service and these types of services are great, right? Being able to get that sentiment information is important, but it doesn't cover everything. So we're going to talk about how can we go now from getting that baseline AutoML model to taking a open source state-of-the-art model from a research paper on GitHub and start incorporating that and training that into something that I can use in my production use case. So I'll give you an example of where this traditional model, it's nice, but can also struggle. So if I said in my retail setting, in Tailwind Traders, we get a review like this. I love the shirt, but I hate the pants. Now, I'm going to ask really quickly in the audience, how many people think that this is going to give me a positive response? OK, we got one or two. How many people think I'm going to get a neutral response, that the love and the hate is going to balance out? And not to be pessimistic, how many people think I'm going to get a negative response? OK, let's see. Well, let's run this model. We're going to click Analyze here. And look at that. I got a negative response, even though clearly I loved the shirt, but I hated the pants, right? So there are two different things going on here. And this is really interesting. Again, we're going to Harry Potter World tonight in Universal. It's kind of disappointing, because if J.K. Rowling were here, she would say that love should beat Trump hate. But I guess in some of these sentiment analysis models, it goes the other way around. I know, I see you. But what I would say is what would be really, really powerful is if we could do what's called aspect-based sentiment analysis. What would be really, really powerful is if we had a model that we could take, and we could analyze what are the elements that I care about for my business, whether that's the shirts or the pants. And then based on the relations between that and other sentiment words, we could identify sentiment on each of these items, and now we have actionable insight. And that's what we're going to do today. We're going to use an open source framework called NLP-Architect, developed by Intel AI in Israel, and we coordinated and collaborated with them to take this network and run it using the Azure Machine Learning Service. So when we talk about the Azure Machine Learning, and yeah, all the slides, everything's going to be available, so if you take pictures, please do, but also I'll put links to how you can get all the content at the end. When we look at the traditional machine learning process, we like to break it down into 3 specific stages. The first is your data preparation. This is how we get all the data from out of the endpoints where we're getting all the reviews, how we process it, how we get it cleaned up. The next is the experimentation phase of, now I have this data set, how do I build a model that allows me to model and generalize the distribution of the data that I have? How do I iterate that? And then the last step is, how do we deploy that and manage the DevOps, MLOps off pipeline? In this talk, in the remaining 23 minutes I have, we're going to look at the experimentation phase of this process. And you can imagine that this can be very, very complex for companies where machine learning or data science isn't their core business. And we're going to look at why that is and how the Azure Machine Learning Service makes this easier for you. So for example, even for the largest tech company, you can have challenges with things such as environmental dependencies and making sure that your train and your evaluation environments, as they change, that things work as they should work. Being able to, when we're dealing with Tailwind Traders, we're a global company. So we have globally distributed teams. How do I make sure that I'm keeping track of what every individual member across multiple teams is doing and making sure that we're optimizing and marching to the same beat to get the best results possible? How do we do things such as data and compute management and scaling up how we store our data, how we manage access to our data, making sure certain teams have access to specific parts of our data sets in ways that are compliant? How do we deal with the compute management and making sure that we're not spending money for very, very expensive GPU compute just when we're doing simple things like data processing or writing basic, logistic regressions? We should only use the compute when we need that compute. Additionally, and again, we have a global company here. As part of a global company, you deal with global compliance. So how do we deal with the fact that in different regions across the world, we're going to have different architectural compliance issues? And David touched on this a little bit in his session. I think it's really important when we're dealing with ethics and the ramifications of AI. How do we express interpretability, right? And the one last thing, and again, I know this is getting overwhelming, but now you can kind of get a sense for how powerful these tools are, is how do we manage distributed training and the ability to run multiple experiments on the same compute, right? So I'm going to tie these all together just by looking at that distributed trading example and some of the challenges we have. And then I'll show you exactly how in Azure ML we address some of these issues for you and provide a more seamless experience that allows you to get from open source to production. So the first thing that you would have to deal with are dependencies, container management. We talked about that. Scheduling jobs across all the nodes and clusters. How do we distribute data and ensure that each of the different parts of the model get the right parts of your data set? How do we deal with scaling resources up and down, provisioning VM clusters, doing things like how do we get the results out and make sure that there aren't any race conditions when we do that? How do we secure access and make sure that there aren't malicious actors messing with the different run nodes and making sure and make sure that the data that we've developed or the model that we developed actually represents the data and not somebody who's abused one of our nodes? And how do we handle things such as failures and rollbacks without losing everything we're doing? You can imagine if I'm running a model on a huge data set and it's taking me a month to train this model and I get to the end and it fails, I wouldn't want to lose everything. So how do I snapshot the different weights? How do I manage that across multiple teams? These are the types of things that services such as the Azure Machine Learning Service make a lot more accessible. And one of the ways we do this is through autoscale and distributed training APIs that natively integrate with OpenMPI and Horovod. Additionally, each of the clusters and compute targets that we create can be shared by multiple experiments and multiple jobs in parallel. Additionally, and if you're interested in this stuff, we're gonna give a demo. I'm gonna take a 5-second break so that everything's in the documentation here. And then we're gonna drive one step deeper into this with distributed hyperparameter tuning. And this is really important when we're dealing with how do we go and why distributed compute is so important, because hyperparameters are a really big issue when I'm taking somebody else's model and applying it to my real-world use case. So for instance, some of you guys may have heard of BERT, right? And some of these amazing models, such, or the model that we're going to be training today, such as the aspect-based sentiment analysis model. Each of these models, when we evaluate the results and we see the results, they're typically trained on standard data sets that are known in the domain. For example, here we have things like Squad, or we have things like the GLUE benchmarks for natural language processing. Computer vision, you might have things like COCO, data sets like COCO or ImageNet. And what's interesting is when typically we see these state-of-the-art, better than human performance results, typically these models are fine-tuned for that data set and that data distribution. Now you can imagine when we take that model from GitHub and we want to train that model now on our data, we have to be aware that the data distribution is not the same data distribution as the data set that those benchmarks were tuned on, right? So we have to retune a set of hyperparameters, whether those are things as basic as the learning rate and the number of layers of our model, or if they're things more complex that are fine-tuned, like the number of aspect thresholds or opinion thresholds for the model. And traditionally, as somebody who comes from a research lab, the way we do this is we take our data set, we develop the algorithm that we think is going to be the best algorithm, or we clone it from the internet and then start iterating on it, right? We choose their hyperparameters, and then we get our first model. And then the next thing we do is we say, OK, what if I change these hyperparameters? Do I get a better model? And then I do that again and again and again, and then I realize I don't think I can optimize this anymore, and I change one thing in my model, and now I have to start that whole process all over again in terms of fine-tuning. That's crazy. That's complex, tedious, repetitive, time-consuming. It's crazy to do that. What if we had a service that helps you manage this in a distributed manner? And that's one of the things that the Azure Machine Learning Service provides through Hyperdrive. Essentially, what it allows you to do is it allows you to provide the service with a set of hyperparameters, allows you to define your own custom benchmarks for optimizing your model, and it will run multiple instances across that search space using many different policies that you can read about more in our documentation, things like bandit policies and truncation selection and Bayesian optimization. And if it sees certain models are not converging, it will kill those and allow you to spin up a new model or just end your session and save money on that compute. So if you're interested in the service, I'm going to show you how to get started with everything I've been talking about. But you can take a picture of the documentation right here. Perfect. So the next step is all of this is great, and I've talked to you a lot about high level how this API works. How do we get started? And I'm going to walk you through very quickly what the flow is and what you need to do, and then we're going to go through a notebook and we're going to do this ourselves. So the first thing we need to do is we need to write our experiment code, our traditional, whether that's a PyTorch or whether that's a TensorFlow project or whether that's any custom project like the Intel AI library that we're going to be using for NLP-Architect. We write up that code, and we define the environment that we need for that code to run. And what the service will do is it will take this snapshot, we'll create a Docker image with all the dependencies and managing and snapshotting all the dependencies we want. It will link it to a compute target that we defined. It will pull from the data store where we've put all our data set. launch the script. And what's very, very powerful here is all the logs and all the streams and everything that we have coming from the service are available to us in real time. So it's as if we're developing from our device. So to do this, there's 8 simple steps. So we distill this down to 8 simple steps. The first we've already done. We need to configure a workspace. The second is we need to define a compute target. You saw how to do that before, and we'll show you programmatically how to do that in a second. We need to upload our data set to the service. We need to create a new experiment. We need to provide the train code. We need to run that. And then once we're done, we need to just register the outputs and package them up for deployment, and we're ready to go. So that sounds like a lot, but I'm going to show you in the remaining 10 minutes how we can do that in less than 10 minutes. So the first thing that I'm going to do here is I'm going to go back to my Azure Machine Learning workspace. I'm going to select Compute, and I'm going to use what's called the Notebook VMs. What the Notebook VMs do is they allow me to very quickly iterate and spin up a version of my model before I scale it with the Azure Machine Learning Service in a local environment. I like to do that as a best practice, because that way, before I send a big batch job, I can ensure that everything runs on a small subset of my data, and then I can scale that out on the full data set and the full compute environments. And we're going to open up our specific notebook here for aspect-based sentiment analysis. And again, everything here that I'm showing you today is open source and available for you. And we're going to walk through each of these steps. So the first step that I need to do is we need to initialize our workspace. 5 lines of code. From Azure ML.core, import workspace. We just load a workspace from config, or we take these 3 things, our subscription ID, resource group, and workspace name. With that, now we have our workspace. It's linked to the exact same workspace in the API that I saw in the UI. So now, the next aspect of this is we need a compute environment to run on. What's really nice about the work that Intel did is that the compute environment that they have runs and is optimized for CPU. But if I wanted, I could spin up a large cluster for GPU compute, which allows us to distribute and use GPU resources. And what's really nice is this is something that this management of compute used to take hundreds of lines of code. We can do it in 5. All we need to do is we import the compute target, AIML compute, and just the exception for handling if there's any issues with our network connection when we want to deploy. We just provide a name for the compute target, and then we just one line here, compute config, Azure ML compute, provisioning configuration. We choose what size of VM we want. We can even choose the priority, this is what's very, very cool. We can use low priority VMs, which essentially cuts cost by an order of magnitude for batch jobs. So another best practice, if you're doing this, definitely evaluate using low priority VMs. We choose max nodes and min nodes, and this enables our cluster to auto scale to the demands of our code. So for instance, if our code is only in the beginning doing a lot of pre-processing and doesn't even need the GPU because we're not running anything with GPU, then we can start very low. But when we need more and more and we're working with bigger and bigger batches, we can scale out. And when we're done with that, with processing those batches, we can scale back down. And this is also really powerful, like we were talking about with the Hyperparameter service. This enables us to run multiple experiments in parallel on different clusters. So the next thing we got to do is we upload our data set, and we can do that in literally just 2 lines of code. All we have to do is dataset workspace.get default data store, or we can use any blob store that is associated with our account. And just dataset.upload, we provide the path of where the dataset is and the target folder where we want to put it on our file store. There's a couple different things like overwrite and show progress. And with that, now we have our data set that can be used by whatever train script, and it can be as big as your data lake provides, right? The next thing we need to do is we need to write a train script to actually train this model. So we're going to be training this aspect-based sentiment analysis model. Again, the code for this has been been abstracted for you, so very, very easy to understand. The first thing we need is we provide the hyperparameters. If you want, we default them. So we default them to some default settings. We pull the models that we need as baseline models for this, which is dependency parser and glove embeddings. Then we pull all of that information down. We initialize this object that's provided by the Intel API called train sentiment. We provide our aspect threshold and our opinion threshold. These are two configuration variables that help us manage how many aspects to find and how many words we should determine that affect the aspects of our sentiment analysis model. We then run, just called train.run, which behind the scenes, and again, if you're interested afterwards exactly in all the specifics how this model will work, I'll walk you through everything you want to know. But when you run this train.run, it will give you the two things that you need to evaluate it. And then we can do one additional really cool thing with this model. So the aspect-based sentiment analysis model that we have here is an unsupervised model, meaning we don't need any labeled training data to train it. That being said is, if we have training data, we can use that to benchmark a little bit, and we can use that for the hyperparameter configuration. So what I've done here, and again, all of this is open source, I've annotated a small little set of labeled data that we can use to fine-tune the model using our hyperdrive service. So once we have that, we just save this file, and we just need to create an experiment. Again, very simple. All we do from AzureML.core, import experiment. We give our experiment a name, and we just link it to our workspace. From there, we create an estimator, and in the estimator, we provide the parameters that we want. So we'll use the default parameters for this run. We pass in our data store, where all our data is, and we just provide the source directory, which is the local directory here where all my code is. We provide any of the script params, in this case, just our data set, right? We provide the compute target that we defined earlier, the thing that auto scales. We can hard code any environmental variables we want. So in this case, we're going to tell the service only to use the CPU to reduce costs. We provide our entry script, that same script that you saw me write 5 seconds ago. And we can provide any dependencies like pip packages and conda dependencies. And what's really cool is we can even build them remotely from Git. Once we do that, we submit the experiment. And I'm going to pull up an experiment that I already ran so we can see how this works. So this model took about 3 hours to run, distributed across a huge amount of samples, as you can see. We can see all the logs here. This is the driver log, and we can actually see the different run logs as well. And we can also, so we can see that we ran this across over 27,000 different records here. And we ran it multiple iterations. And again, we have a model that was trained in about 3 hours. And we have all our metrics that are associated with this. So things like the amount of aspects that are relevant to us from this model, the opinion size, and we even, because we used a test set, like a validation set, we can even calculate an F1 score that will later be useful for benchmarking. Now what's also really cool is if I go back into my workspace here in experiments, I can dive into this exact same run, and I can see all the run logs as they load. And additionally, I can see all the code that was associated with this experiment. So that's, if you think about it, that's extremely powerful, because what it means is if I have a distributed team all over the place and people are running different experiments, and I see that something that worked that one team did based in Redmond and another team for Tailwind Traders did something based in Tel Aviv, I can see exactly in the code where the changes are and integrate that into another experiment. And when I look across the metrics, I can view a chart of every single run across the entire experiment, so I can keep track of that across a globally distributed team. So let's go back here and let's start spinning things up. once I'm done, all I need to do is register the model. So we have this aspect lex and opinion lex. And then we're ready to test this model either locally or deploy. And so in order to do that, I'm just going to load the model from Azure ML. Again, very, very simple, just a few lines of codes here. Import the model. Import inference from the NLP-Architect. And then all we do is we get the path of the model from our model store. And then we can just inference it locally or as a service, as we'll see in a minute. And I have a couple examples here. So for example, loved the sweater but hated the pants. Really great outfit, but the shirt is the wrong size. Or I absolutely love this jacket. I wear it almost every day as a cardigan or a jacket. My favorite purchase so far. And when we run this model, we can now visualize the results of that run. And you can see, instead of just getting that straight up value that we saw in text analytics before, we can actually get specific sentiment associated to the aspects we care about. Things like the sweater and the pants, the outfit, but we see that the shirt is negative because it was the wrong size. And that's actionable, something that's very, very valuable for Tailwind traders. So the last thing that we want to do is we're going to want to take this model and package it up for deployment. Very, very simple. We just need to implement one interface here, two functions, init and run. So in the init function, we just put in all the one-time operations. In the run function, we put in the operations that we would run when we get our text data as input. We can send in raw data or JSON or whatever we're used to. We set up our evaluation environment, which matches the environment that I used in the train, but it could also be a different environment if I need. Create this, wrap it up in a config. We use the inference config here, and what this does is this takes that same deploy environment that we had before in the score.py, and once we do that, we can just type model.package, provide our workspace, the models that we registered, and that inference config, and now we have a model that can be deployed, and we'll see what that looks like in the next session. And the last thing that I want to show, and again, we're almost done here, but the last thing I want to show is here we can use that same hyperdrive service that we talked about to optimize things. So we had a whole list of hyperparameters here that I hard-coded before. I can do different sampling. I just provide a termination policy that allows me to, again, terminate different runs that I don't believe are converging. Here we're going to use a median stopping, but I have documentation for everything in the notebook. We go to hyperdrive config, choose the metric that I want, in this case F1 weighted, which I logged here in the train script, but can be anything that you want it to be. We run that. So we grab this and we run this, and we can actually see the results of a model I ran, and you can see multiple runs, the best metric, and you can even see specifically how the different changes of the hyperparameter space have impact on your model results. And again, everything can be done here in Jupyter, but also through the UI as well. And once we've found the best model that fits the best metric, I can then wrap that model up and deploy it. So with that, let's wrap everything up. I think that it's important to take a step back and see what we covered in the past 40 minutes. We covered so many things like we reviewed the different advances across the AI industry. We talked about text analytics and cognitive services and talked about the 80-20 rule. We built a custom baseline model for sentiment analysis with AutoML. And then we took an open source state-of-the-art model from an open source repo in GitHub, and we used Azure Machine Learning to train and try out that model more cheaply than I would be able to do and faster than I would be able to do on my local device. And the key takeaways here is that AI is driving a ton of advances in different industries. Everything that you saw here that's based on this specific scenario of sentiment, aspect-based sentiment analysis can also be applied across computer vision, forecasting, everything that we saw in the beginning. That AutoML and cognitive services help us build AI fast and get quick baselines that we can then go and drive even deeper with the Azure ML Service that reduces a lot of the burden of ML ops from the end developer and data scientist. The last thing that we noticed is when we're doing sentiment analysis, aspect-based models, if you haven't heard of them before this talk, are something that you might want to evaluate because they give you another level of actionable insight. And that taking third-party open source models, they can be more easily trained in a distributed manner on Azure ML than if I had to do that myself. So with that, I'm just going to quickly wrap up here. Documentation about the service here. And another really important one, everyone I would recommend and suggest that they take a picture of this. This has a bunch of quick things such as the text analytics API link, automated machine learning documentation, all the stuff you saw around hyperparameter tuning and the ML services. But in addition to that, there's been a lot of amazing work being done by the Microsoft product teams on GitHub showing recipes of best practices across many of the scenarios, including the scenario I showed you today in natural language processing, computer vision, recommendation systems, and more will be coming out shortly. And every single one of the points that I touched on today, I've also written a blog post called 9 Advanced Tips for Production Machine Learning that you can deep dive into, and everything is encapsulated there. Last quick small things. We got all the ML Learn modules. Yep, I'll let you take a picture. And they're all linked to this in the AIML40 MS Learn collection. We got certifications. So all the certifications are free this week, as you probably know. You got 2 days. I would strongly suggest checking them all out. And with that, the last thing that I would recommend is now that we've trained a model, if you're interested in how to put that model into production and manage your DevOps workflow, I strongly suggest you stick around for the next session, AIML40, that's going to be delivered by my talented friend Damien. And with that, thank you so much for your time.